So in last video, we learned about what a parallelogram is and its properties. But now we need to see how we can show that a quadrilateral is actually a parallelogram. So this is what this video is focused on. Next video, well, next time I cover the chapter, should be on special quadrilaterals. So we have a bunch of converses to get through. These are just the converses of the theorems we saw in last video. Or the last lesson. I don't know if this is actually going to be the last video. So the first converse is the opposite angles converse. So if a parallelogram has congruent opposite angles, if a quadrilateral has congruent opposite angles, then the quadrilateral is a parallelogram. So this is all just the theorems we learned from last video, but just their converses. Remember back to conditionals. P implies Q, so our P, this case, would be if a quadrilateral is a parallelogram. So those would be the parallelogram theorems. But we swapped it around, so now in these theorems, our then would actually be the if in a theorem, and if is actually the then in the theorem. I'm sorry that's confusing, but just remember back to conditional statements. I don't know why is there a word that says quadrilateral right there? So now I have the opposite sides converse. So opposite congruent sides in a quadrilateral implies parallelogram. Consecutive angles supplementary implies parallelogram. And diagonals bisecting each other imply parallelogram. It's really simple. But now we have a new theorem to look at. So this is not a converse. This is a theorem. So opposite sides parallel and congruent theorem. If a quadrilateral has one pair of blank and blank opposite sides, then the quadrilateral is a parallelogram. Well, it kind of says it in the name. So, wait, what? Oh, parallel. Wow, that is beautiful handwriting, if I must say. So this is our last theorem. So if we have a parallelogram with at least one pair of congruent and parallel sides, so if we just say there's a quadrilateral and all the lines are straight, then this is a parallelogram by the theorem we just saw above. That brings me to our next point. What are the different ways to prove a quadrilateral is a parallelogram? Jeez. So we can use angles to show that a quadrilateral is a parallelogram. So if we have opposite angles congruent or consecutive angles supplementary, then it has to be a parallelogram. And that goes back to the theorem's opposite angles converse and the opposite consecutive angles converse. And sides. If we show the sides are congruent or parallel, or we show that one pair of sides are opposite and parallel, are congruent opposite sides. Wow. Let me repeat that. If we show that opposite in a quadrilateral, the opposite sides are congruent or parallel, or we show that one pair of opposite sides are congruent and parallel in a quadrilateral, then the parallelogram is a parallel. Oh my God. The quadrilateral is a parallelogram. How many times have I said parallelogram in this video? Sheesh. So that goes back to the opposite sides converse and the diagonals opposite sides and this theorem. And now we have diagonals. So if we show that two diagonals have the same midpoint, then they bisect each other, and that brings us to the diagonals converse. And how does that really make sense, though? Imagine you draw a quadrilateral and we connect our vertices. And we draw diagonals. For these to have the two midpoint, they have to meet up at their midpoints. They both cross the same point. And at their midpoint, it splits. Remember, a midpoint splits the segment into two congruent parts. So that means they bisect each other. Now we have practice. We're going to identify if the following quadrilaterals form a parallelogram. So, looking at this one, no, there is no information that says it. We cannot assume these are right angles or parallel. Now here, we do have opposite parallel sides and opposite congruent sides, but since they aren't, since there isn't one side that's both parallel and congruent, this is also no. So this question is asking us to show if a quadrilateral with vertices A, B, C, D is a parallelogram. And it's asking us to use diagonals. So let's go back to here. With diagonals, we have to show that the diagonals have the same midpoint. And I already explained how that works. But basically, if they cross the same point, they intersect there. So I like to draw an image for questions where you have to use coordinates. So A, this would be A. And in relation to B, B would be here. I'm just writing it out as imagining it was on a coordinate plane. C would be here. And D would be here. So the diagonals are B, C, and AD. So first we want to find the M of AD. And I'm just referring to slope, don't forget. Sorry, not the slope. My bad. We have to find the midpoint of it. Of AD. So this is -1 plus 2 over 2. 1 plus 0 over 2. So this just simplifies to, well, 0.5, 0.5. And I'm not going to write it out as a fraction because that takes forever. And BC, same thing. This is not the measure of BC, but I'm just too lazy. And really, that just simplifies to 1, 2. Both 2. Because 1 plus 0 over 2, 1/2. So as you see, they both have the same midpoint. So what this means is, yes, this is a quadrilateral. And now we're going to ask to use the sides to see if QBCD is a parallelogram. So with sides, that means we can either use the theorem here, opposite side parallel and congruent, opposite side is converse, or anything, definition. So I like to use a definition with slopes. So Q, 0, 1 would be here. 0, 3, so here's Q, here's B, here's C, and D would be right here. So you can obviously tell this is not a parallelogram, but you're going to ask to show. And by show, you actually have to show by not just plotting it. You have to show that it makes sense. So with sides, let's just see, well, BQ and CD, because those are the two obviously non-parallel sides. BQ, so the M of BQ, the slope, is 3 minus 1 over 0 minus 0. So this is just a vertical line. This would be a vertical line. In the M, the slope of CD is 1 minus 3 over. So this is 1, -2, or -2. So no, this quadrilateral is not a parallelogram. So in conclusion, in this video, we were able to figure out how we can show a quadrilateral as a parallelogram using the converses and all the theorems we learned. So now next video should be on special quadrilaterals, unless I want to focus on 2-column proofs. However, I'm not 100% sure what I will do next. I might not even have 2-column proofs, because some places don't do 2-column proofs. However, I did make a custom final, and I did put a 2-column proof on there with parallelograms, so maybe I should focus on that first. And if I don't, there will probably be one after special quadrilaterals then. It would make a lot of sense too. But really, this is how you show that quadrilaterals are a parallelogram. Using the converses of all our theorems, and using the opposite sides, parallel, and congruent theorem. So that is it.